Alright, so in this section we're going to be talking about the states of matter. Technically there are 5 main states of matter. We're really only going to focus on 4 of them, but the 5th one I did post a video about. It's either known as supercritical fluid or superfluid. And it's kind of a weird state of matter because the substance acts like both a liquid and a gas at the same time. So it's pretty interesting. It's got some really cool properties to it, so I'll leave that for the video. But so first up, we need to talk about the kinetic theory of matter. So matter is made up of atoms, and then those atoms can combine to form molecules. Atoms and molecules are tiny particles, and the kind of weird thing to get your head around is that they're always in motion. So even in solids, the molecules, the atoms, are basically vibrating back and forth, okay? And that motion is actually related directly to temperature. So temperature is basically a measurement of the motion that's in a material. So the higher the temperature, the faster the particles move. And then at the same temperature, larger particles are going to move slower than smaller ones. Okay, so you can think about this with people as well. All right, if you've got a toddler versus a sumo wrestler, okay, basically if they have the same amount of energy, toddler's still going to be bouncing off the walls compared to the sumo wrestler, right? So the 4 main states of matter that we're going to talk about in this chapter are solid, liquid, gas, and plasma. So with a solid, solids have a definite shape. Okay, you can change that shape, you can make it smaller, you can make it bigger, but they will have a definite shape. They also have a definite volume. Okay, so this is how you can define a solid, really, is that if it has a shape and a volume, it's going to keep those. Okay, a solid, if you look down at the particles, they are going to be relatively well packed together. Okay, there is going to be motion in there, simply because, everything has motion on the atomic level, all right? In fact, there is actually, when you talk about the Kelvin scale for temperature, which we're going to get into later, it is actually defined based on where this motion ceases, and that is called absolute zero. So at absolute zero, all of that vibration in the molecules, in the atoms, is going to stop. Okay, we haven't actually reached absolute zero, but that is the theoretical temperature where all motion ceases. Okay, so anything that's above absolute zero, even a little bit, will have that motion involved. Okay, then when we go up to a liquid, so liquids are going to have indefinite shape. Okay, so liquids will take the shape of whatever container they're in. Okay, and if they aren't in a container, they tend to just kind of pool outwards. All right, and then they will still have a definite volume. Okay, they will not expand to fill whatever container they're placed in. Okay, so if you kind of think about how like water in a bowl acts. Okay, that's what we're talking about here. It does have a definite volume, so it's not going to fill the entire container, but it does not have a definite shape. And in liquids, you're going to see the particles moving around each other a lot more. So they have more motion. They're able to move past each other a lot easier. They're not just vibrated in place, but they're actually moving around this time. Okay, that's why they don't have a definite shape. But they are still held relatively close together, which gives them the definite volume. When you get up to a gas, okay, this is where you have an indefinite shape and an indefinite volume. Basically, gases will fill whatever container they're put in, okay, whether that's the room, whether that's a vial, whether it's a beaker, anything like that. Okay, so it will fit the volume and shape of whatever container they're in. Gases have the most vibration in the particles, so they are moving around like crazy. They are literally bouncing off the walls of whatever container they're in. Okay, bouncing off anything and everything in that container. whether that's other gas particles, whether it's a solid particle, whether it's a person, whatever. And then the last state of matter that we're going to talk about is plasma. Plasma is really kind of interesting. We don't see it as much as the others, on Earth at least. It's basically an ionized gas. So it's an electrically charged gas where the electrons just kind of jump off the particles. Okay, so you're going to have positively charged neutrons, or nuclei, and then you're going to have the electrons just bouncing around all over the place. Okay. Now, this is actually the most common state of matter, even though we don't necessarily see it all over the place on Earth. Okay, it does make up about 99% of all known matter. And there's a really easy way that it makes up that much. Okay, it's the matter that is found in stars. Okay, now if you think about how huge stars are, that's why it's 99% of all known matter is plasma. So stars, lightning, the aurora borealis, or the northern lights. So stars, okay, it's in plasma. You've got lightning is one of the most common forms that you see plasma on Earth. And then you've got the northern lights. You can also have plasma in like neon lights. That is a gas that gets ionized. Okay, so it basically loses its electrons, and that's why it glows, right? It does also conduct electricity, okay? So if you've ever seen a thunderstorm, you know that, right? Now, when we get to the extra credit in this chapter, I'm actually going to be talking about people who get hit by lightning, okay, and the kind of effects that they deal with, because it is, I mean, plasma is not really something you want to mess around with, especially if you don't know what you're doing. And getting struck by lightning is just, I mean, it's bad. It can screw up a lot of stuff inside the body, but it's kind of fascinating when it doesn't happen to you. But anyway, so I'll leave that for the extra credit when we get there. Okay? So that is it for this section.